Let's examine some of the functions of a typical switched daylighting control system. We know it's going to switch lights off and switch them back on. There will be a number of different types of devices which you can install on control inputs to the controller, timers, aux sensors, whatever. We're not going to even speak about them generally right now because we're concerned with setting up the daylighting response of the system. You'll always need the instructions. You're doomed without the instructions, and I've got to tell you, for the uninitiated, the first time you look at the instructions for a switch daylighting system, and I'm no chimp, these things are a little confusing. First of all, you have to understand their terminology. I have slang names for these points, but the manufacturer will have their own names. So these are what the manufacturer calls the cut-in points. You have to imagine this graph reversed for the afternoon. As the sun begins to go down toward sunset, a stage of light snaps on. As the sunlight begins to decrease again, a stage of light snaps on. These are referred to in the instructions as the cut-in values, and they are entered directly. And there is a small time delay, and it's measured in seconds. The time delay for shut off, or cut out as they put it in this product literature, is in minutes. Why? Because as sunlight comes down, you don't want it to drop below your reference illuminance. It's not allowed to get down here before turning on a set of lights. So, when you are flirting with going below the reference or going below your set point, the time delay is in seconds before it snaps on. Now, it's different snapping the lights off or the cut out. When you reach the cut out, this time delay is measured in minutes, because the last thing we want to do is suddenly have the lights drop too far below, or even just shut off unnecessarily. Clouds, this, that, the other thing. Now, these points are entered directly into the controller, but these points, the cut out points, are not explicitly entered into the controller. They are based on this value, because you see, with no time delay or anything, or deadband, these lights would simply switch on and off at exactly the same point. But in a switch system, that's likely to cause oscillations and snapping on and off of the lights. So there's a deadband installed, and the minimum you can put in is 10%. And the way this works, this is your cut in value, your cut out value is cut in times the deadband, which is in a percentage that you have to convert to a decimal, plus the cut in. In other words, if I have a 10% deadband, then my cut out value will be 10% higher than the cut in value. So if I have said, when the sunlight's coming down, I want this stage of lights to snap on when I'm at 40 foot candles, with a 10% deadband, which is the smallest you can put into the device, the cut out will now be 44 foot candles, because you have a 10% deadband. If you have a 20% deadband, this would be 48, etc. So that is the function of the controller. These are the names of the things that we're going to be telling the controller. We're going to be specifying these spots plus a deadband, which will give us our cut out points, and we're going to be specifying this value at the task surface. The controller will then compute its value for its own sensor, because remember, this is all it can see. It can't see what's inside the room. And these cut in and cut out things will be triggered by taking this value and multiplying it by the sensor ratio and applying it to the input for this thing, and it'll be looking for the points based on the input of this thing. Now let's look at how we compute our set points that we're going to enter into the controller.